Welcome to Unit 2. Congratulations on finishing Unit 1, and I hope you learned lots about quadratics. And if you had any questions, I hope you have clarified it before starting this new unit. But welcome to our first lesson, Lesson 12, and we are now learning about characteristics of functions. So you've heard me use functions a lot throughout this course, and today we're going to focus on what a function is, its definition, and how to distinguish between a function and a relation. So, or relations that are not functions. So before we start the distinguishing, we're going to start with some vocabulary. So first, we have a mapping diagram. So a mapping diagram pretty much maps our input values to our output values. So it shows a relation between the x and the y, or again, the input and the output values, which don't necessarily have to be x and y, they could be different variables. And it shows it through a diagram such as this, where here we have our input, or x, and our output is on the other side, or y. And we see that there is a relation between different values of the input to the output. So -1 goes to 1, -2 goes to -1, 0 goes to 3, and so on. So this is actually the mapping diagram for the function y equals 2x plus 3, where we see that each of the input values are being doubled, and if we add 3 to it, we do get that output value. And we only are given 5 input values, -1, -2, 0, 1, and 2. And these are the set of my input values, so x here. And notice that this is not the same order here because the order does not necessarily matter as long as that relation is showing. So you can see that here, 1 and -1 do correspond to their input value. They're just not in the order that you would expect, but that relationship still holds. So now a function is a relation, but there's exactly one output value for each input value. So for example, in y equals 2x plus 3, we know that that is a straight line, and it's a straight line that goes upward, similar to that. So each value of x has a specific output value y on this line. So this is actually a function, and it's a linear function, so the straight line. A function itself just is any mathematical rule that takes a set of input values. So for example, here we are given the set x as 1, 2, 3, 4, and this is our domain. And this machine or our function performs something, some actions on the input value to produce the output value. So here that action is given as x plus 5. So any value of x that goes in this machine is added, it has 5 added to it to provide that output value. So here we see 6, 7, 8, 9, which matches to our input value. So the function above as well, we see in the mapping diagram, for every input value, there's specifically only one output value that um, the line is drawn to. So we do not have, for example, from -1, another line going to 5. If we had that, this would not be our function. This would not be a function. So now we're going to look at some common representations of relations and functions. So these are the ones you've seen before, and now we're putting it all together. So one way is set of ordered pairs. So here we see that for every input value, there is one distinct output value. So this could be a function. So next we have our set notation, which is similar to the set of ordered pairs, but our x and y is now separated. So we're not writing the points anymore. Here we have the input and output value grouped together, but here we have all the input values and all the output values together. So in the set of ordered pairs, you can see that relation between the input and output a little bit more distinctly, whereas with set notation, we can necessarily see that connection right away. But if you look at these two, I hope you see it as the values for just the quadratic function y equals x squared, which holds for all x and y. So this is just a set of the whole number values for that function. The next representation is just our equations that we've been seeing, and that also is called function notation. So whenever we have y or f of x, which is our output value, equal to an algebraic expression for or an algebraic expression using our input variable, which is x in many cases, but not always. And that would just be our regular equations that we've seen. And some visual representations now are that mapping diagram we saw, a table of values, which we've also seen, and graphs, which graphs could be different shapes. This one is for a quadratic function, but we've also talked about linear functions, which have straight line uh, graphs, and those would still be functions. So these are all the different representations for relations, and based on these, we can find methods to determine whether these relations are functions or not. And that's our goal for today, to figure out how to determine whether these representations could be a function. And essentially, to do that, we are just going back to that definition of function where for each input value, there is exactly one output value. So if that holds, then we can say it is a function. So now, looking at function notation, this is just a review, but f of x is called the function notation, and it represents the value of our dependent variable. So our dependent variable is y, or f of x, for a given independent variable, so x. So it pretty much tells us the value of y for a given x value. So here, just take a moment to pause and try these on your own to see if you get the same answers. Okay, so for the first one, we just substitute in 3. You just make sure you got 23 there. The second one, we have half. Stick with fractions. When you have fractions, it's easier to work with exponents, so we get 2 over 4. And here, this just becomes 2 to give us 1. For here, the trick was 5 minus 3. We have to follow order of operations, which tells us to do the bracket first. So you actually are doing 5 minus 3 to get 2, and this is the same as f of 2. And if you evaluate, you get 13. However, this next one for D, it's f of 5 take away f of 3. So you have to calculate f of 5 on its own. And for f of 3, I hope you remembered we did f of 3 for A. It was 23. So 64 minus 23 is 38. So now let's practice, is it a function? So consider the table of values, these two table of values here. And I've also given for you their mapping diagram and their function, or their graph of the function, or the graph of the relation. So now, which relation is also a function? So take a moment to look, and based on the definition of function, see if you can figure it out. So you should have got that example 2 is our function, because for every input value, there's a distinct and only one output value. Whereas for here, we see that 4 could be -4 and it could be 4. Same with 2. It could be -2 and it could be 2. So on our graph, if we had plotted these points, and let's specifically look here, we see that these two are both output values for 2. And same here, these two are both output values for 4. Whereas here, we have 5 distinct points, and they do not interfere with one another. Specifically, we are looking at a vertical line test, which is a test that, based on the graph, can tell us whether a relation is a function or not. So you would be drawing a vertical line through the graph, and at any point within this graph, you cannot pass through more than one point. So if you do, it is not a function. But if each vertical line passes through only one point, then you have a function. For example, here, let me start with my straight vertical line, and then we make it red so we can see. Through this point, there's only that one point. Through here, there's only that one point. Same, 1 point, 1 point, 1 point. So this graph passes the vertical line test, so it is a function. That being said, looking at here, we see that over here there are 2 points, and same with here, there are 2 points for our vertical line test. So this one is not a function. And you would have been able to see that from the mapping diagram as well as the table of values as well, specifically because 2 has 2 output values. And here 2 also has 2 output values. So here, we're going to apply the vertical line test. So let me draw my line one more time. So this one, I see that at any point, at many of the points, there are 2 points. So this is x, not a function. This one, however, and don't let your eyes be fooled because it kind of looks like it's a straightish line here, or like that there's multiple points. But if you keep zooming on this to get to very close to one individual point, you see that it will actually pass the vertical line test. And this is our one of our main functions as well. So here we have our parent function or our quadratic function. So this one surely passes the vertical line test, so yes. Here we are seeing another function that will pass the test as well. So this one is also a function. Keep in mind, we are not doing a horizontal line test where we see here that many points are shared. It's a vertical line test. So vertically, all of these points pass. That being said, though, on this function here, it does not pass. So this one is not a function. And over here as well, similar to B, if you actually zoom in to the points, you will see that this is a function. And at no point on the vertical line test will we have 2 points on our vertical line. And that is our lesson for today. So not a lot, mostly just focusing on different representations of relations and functions that you're going to be seeing and you've seen already, and a review on what functions are, different types of functions. So now we are very comfortable with linear and quadratic functions. And in this course, we are going to also see our exponential and one of our trigonometric functions as well. So we would be able to use this knowledge now to check if those later graphs are also functions. For this lesson today, you have some practice problems. So just take some time to match definitions and determine if some relations are functions. And if you have any questions, don't hesitate to reach out, and I'll see you all next class.